So, with the rise of recent discoveries of looking at the red planet, we're seeing dust storms, potential signs of water that was once present on Mars. We're also seeing how water plays into the geological features of the red planet. We're also seeing basically how we can eventually set up a biosphere that we can send the first humans on Mars and rebuild and replenish the Martian world. And how did that become a dry, cold, desolate red planet that it is today? Well, let's talk about the whole history of Mars, and we're going to see how that compares to what's going to be happening in the future of future exploration. So let's get some insight about Mars. So Mars is the fourth planet away from the sun, located about 140 million miles. Mars is named after the Roman god of war, derived from the Latin word Mars. Ancient Romans associated Mars from its red color as blood and battle. But also they named it after, in Greek mythology, after the god Ares. And the other cultures have their own names for Mars itself and similar attributes of being red, representing battle and blood. So we're going to go over the physical geography of Mars itself. So Mars is also covered in craters. It has many volcanic features where we see the tallest volcano of all, of actually the entire solar system, Olympus Mons. It's located on the northern hemisphere. It rises to an elevation of 72,000 feet above the Martian surface, or 16 miles above the Martian surface. And the way it's formed was over time as lava piles and then cools and piles and cools, and then eventually, since Mars has a very weak gravity, that means the volcano can actually grow past its own, height, so it doesn't like collapse on itself. Mars is also covered in lava plains from ancient lava beds. It also has canyons like the Valles Marineris, which spans the entire United States. So from Los Angeles to New York City, it's a 3,000-mile canyon feature, and also it's 2 times deeper than the Grand Canyon itself. Another thing too is heavily craters from its past. It has North Pole and South Pole being locked up as ice caps, mainly composed of water and frozen carbon dioxide. What else? What else? There's other volcanic types as well, scattered along its surface. Also, physical geography up on a large scale. Its northern hemisphere is actually much lower in elevation than its southern hemisphere. This is due to a collision course early on in Mars's history that we're going to get to that in a little bit, okay? And atmosphere. Mars has a very thin atmosphere, mainly composed of 95.3% of carbon dioxide and small traces of other gases, like more prominent being oxygen and tiny amounts of water vapor that's still existing inside of the atmosphere itself. And like I said, there's ancient water beds that have previously covered the Martian surface, and we can see physical geography as we can see by the recent discoveries on Mars. So that's going over that geography of Mars. So now we get to the actual history of Mars. Also, Mars does have sand dunes as well, just like Earth. And these are also due to wind, and also the older sand dunes that you see on Mars are also due to the factors of ancient water that placed minerals and just kind of shelved them. So with all these recent discoveries that we're seeing, we need to go to the history of Mars, because we have the Perseverance, we have the Ingenuity, we have Curiosity, the ESA, the European Space Agency. We need to understand the basic history of Mars between 4.5 billion years ago to now. We need to understand how Mars formed out of these solar dust grains and pebbles that eventually formed Mars, and understanding as it was formed out of that nebula, all these dust grains and rock pretty much coalesced and formed a ball, a very hot lava filled world that reached about temperatures up to 2,000 degrees. And eventually, Over time, as we get from that Hadean period, eventually we cool down and we eventually all that lava formed a new crust. And eventually water has existed in its early form atmosphere. And but the water couldn't really stay because as you get to the surface, the water evaporated. But as it kept cooling down, you had other traces of water that kept um, pooling up, and eventually the late heavy bombardment period was actually the turnaround that sent water to the first three planets. So we have Venus, Earth, and Mars, eventually having pummels of comets supplying them with water. Water is the most prominent basis of life. Without water, life would not exist. So water has pooled over millions of years and eventually formed oceans, lakes, and rivers. Now, going further down the timeline to 3.8 billion years ago, where all three planets had their first signs of life. Now, most of that life existed underwater, under these shallow oceans. So there's these little chimneys that was whipped up by the hotspots to the planet's interior, and also as it interacted with the seawater, it turns it into steam. But with those chemical reactions of the heat and the early ocean water, that salinity caused a chemical reaction. It created signs of life. And eventually, as that life forms interacted and spread across the planet, they evolved and they became blue green algae. And eventually, that blue green algae eventually formed their own photosynthesis where they can take the CO2 from early signs of volcanism, as it was filling up the atmospheres with CO2. They were eating all that CO2 and converting it to oxygen. So now Mars had oxygen ready. It's already teeming with life. Same thing with Earth, teeming with life, and eventually Venus as well, teeming with life because they had early signs of stromatolites. These are blue-green algae mats that form to like a rock base. And eventually they had life. But pretty like all things must come to an end. Mars had a fate. Now, here's what happened. Deep down in the planet's interior, the core stopped spinning. It cooled down. And eventually, the magnetic field was dissolving. It couldn't supply enough of that electromagnetic radiation and these electrons. They were getting further and further apart. Eventually, it halted. Now, without that magnetic field, it can't protect itself from the deadly solar radiation that the sun was producing because it was active at that time. So eventually, Mars, with all its life, had to learn a fate. That solar wind pretty much bursted out and pretty much stripped Mars of everything. Its early atmosphere and all that carbon dioxide that was also that's left in by these volcanisms kept pumping CO2 into the atmosphere and leaving behind a lifeless hellhole. That all that water evaporated and left into space, and most of that water was also trapped in as ice. Early signs of glaciation periods about 2.5 billion years ago, but that was a permanent ice age. All that water was being evaporated, and all that CO2 that was pretty much prominent in the early Martian atmosphere, and it still is today. All that water has pretty much evaporated and eventually left behind CO2. Now we had CO2 ice that covered most of the planet. And eventually, Mars cannot survive that. Underneath all that life died. And all of that iron that was exposed to the leftover bits of oxygen in that tiny bits of water, fused with the chemical reactions with the sun as well, it turned into rust. All underneath all that ice. And eventually, ice recedes, leaving behind what Mars is today. a cold, barren, red wasteland desert that it is today. And this is due to the permanence of that ice age that dropped the temperatures even lower. And all that water has been locked up as the ice caps, but mainly CO2. No atmosphere, just a very thin leftovers of its early atmosphere, just filled with 95% CO2. So that's the ultimate fate of Mars. No water, just signs of lava that's still present, but eventually that solidify all those traces of metals that were interacting with the tiny bits of water that was left over, interacted with the sunlight and the harmful radiation, rusted completely. So that's why you see dark patches of ancient lava fields that are rusty. So that's the ultimate fate of Mars in its history. Eventually, with all these forms that we're seeing, and eventually all those volcanoes that were forming, when Mars used to have water, there were once these volcanic hotspots that had once had early plate tectonics. We had some called hotspots, just like Hawaii. Eventually, those punched up through the crust and eventually formed volcanoes as they were erupting. And they piled on and cooled and piled on and piled on, got much taller. And eventually, like I said, they keep pumping CO2 and eventually fill the atmosphere with CO2. So now we're into the chapter of the recent discoveries. So what we found recently was the ancient leopard print and the poppy seed structures may have resulted in once Mars had water, all these minerals have deposited. Also, I do have a TikTok that pretty much explains a little bit of these rock like features, these mineral features. I'm going to play that right now. Going back to that physical geography that we want to talk about is also the 1,000 mile wide maze that we've been seeing. Also, it was formed by again water that's been eroding that ancient landscape, eventually digging these jagged rocks and eventually depositing these minerals that have stacked. And that's basically how the South Dakota Badlands had formed, was due to the presence of ancient water that has existed, and eventually as it eventually left, these minerals have pretty much piled on top, eventually forming these jagged rocks that we see in the South Dakota Badlands. And ancient lava fields has also deposited minerals too, because without volcanism, life wouldn't exist on Earth, because lava, as it cooled, it deposited all these minerals. So all these ash and CO2 and sulfurs, they all created life. Without life on Earth, without those volcanoes, life on Earth would not exist without ancient early volcanism. So same thing with Mars, ancient early volcanism, and same thing with Venus. But Venus had the ultimate fate where it was so out of control, where it trapped in a lot of heat and eventually water evaporated and eventually pushed temperatures up even hotter because of the runaway greenhouse effect. Mars, basically, the runaway greenhouse effect only happened just a short period of time. Eventually, the planet got colder because the atmosphere was being stripped apart. So, without that, Earth being the only planet to sustain life in our solar system only existed because it controlled how its volcanism was working. So it took all these plant life, the stromatolites, took in all that CO2 and pretty much released as CO. So took in CO2 and released oxygen into its atmosphere, creating the balance between volcanism and life. So without all that, life wouldn't exist. So I was thinking of doing a separate video talking about just the future of Martian exploration as we're bringing life back to Mars, and how we're going to rebuild an atmosphere, how we're going to rebuild its magnetic field, and how we're going to release the water that was left over, and how we're going to bioengineer the red planets. So that's what I want to discuss in a separate video. Um, I was thinking of doing that in this video, but I want to go over some of that history of Mars in this video. But I want to do a separate video discussing that. So thank you guys so much for watching. I'll see you guys in the next video. Subscribe to this channel and for more space content.